Hi, here I will show you how to flash the BK7231 Tuya Smart Switch with Open Beacon in order to free it from the cloud and pair with Home Assistant. Presentation will include identification of BK7231 pins, and in this particular switch, we will also need to handle the touch buttons controller chip blocking UART lines. We will just temporarily desolder it. It's not always necessary. Most of switches don't have block UART lines. Let's start by taking off the front panel. Here we can see the board with Wi-Fi module with touch buttons controller chip in SOIC8 case, the transistors driving relays and the AMS1117 low dropout regulator that provides 3.3 volt for the circuit. This switch is not using ESP chip. It's WB3S, a BK7231T Wi-Fi module. It's easy to flash BK with UART to USB converter. The basic flashing circuits is shown on the screen. As you can see, only UART and power connections are required. So let's start with soldering the wires to WB3S pads. First, UART receives and transmit lines.
First, add some flags on the pads, then add some solder on the pads, also thin the wire tips. Then, finally, solder the wires to the pads.
We don't need to solder ground and power because ground and power signals are available on the gold pins on the PCB connector. Thanks to the AMS1117 3.3 volt low dropout regulator, we can also power this board directly from USB. USB provides 5 volts for the AMS and AMS provides us with 3.3 volts. Unfortunately, in case of this switch, the programming will fail unless you desolder the SOIC chip. This IC, the buttons controller, is connected to UART lines of BK and must be disconnected before flashing. Let's desolder that IC. Start with adding flags and extra PB solder. PB solder has a low melting temperature. Heat up both sides of the chip. Make sure that solder melts and then carefully lift chip up. Now it's time to use Beaker Writer 1.60 to flash Open Beacon. Download links are in video description. First, start flashing in Beaker Writer, then reboot Wi-Fi module by disconnecting the power. Flashing will proceed once reboot is done. Remember, there is also a second way to reboot. You can do that by shortening the CEN signal to the ground, but that's not needed here. Okay, flashing is complete.
Now we can solder the UART wires.
Remember to solder back the buttons controller in its place after flashing. Clear the board before soldering. Add extra flags and first solder just one pad. Position the chip and then solder remaining ones. When ready, clear the remaining flags from the board. We will also need to know which I/O pins are used for relays and buttons. Again, use a multimeter in a continuity test mode to see which Wi-Fi module pads are connected to buttons controller and to the transistors controlling relays. Remember that Wi-Fi module paths are not connected directly to the transistors. There is also a resistor on the way. It's also worth checking our online device's database first. It might already have a configuration for your device. You can find the links to our database both on the screen and in the video description. Use search function to browse devices. But now, for the sake of an example, let's manually configure the relays. The first relay and the first button will use channel 1, and the second relay with the second button will use channel 2. There are still a few things you can do. If you feel that the switch reacts slowly, you can enable instant press reaction in the flags. You can also configure the MQTT in the MQTT tab and configure the Tasmota device groups in the Configure Device Groups tab. Here you can see the Open Beacon web application panel. In this panel you can access file system for writing scripts.
Here you can also do a firmware upgrade.
Here you can also directly access device templates. It's time for the final test. As you can see, the switch can be controlled both directly and through the web page. Thank you for watching. If you have any question, please visit our forums. We will try our best to support your device. See ya!